thank you very much for the invitation, and it's nice to see you in these strange times, unfortunately in a virtual way, but I hope that we'll meet in some way in the real world. But yeah, maybe this virtual world is better, I don't know, whatever. All right, so today I would like to do some pretty quick introduction to the Watermill. But before that, I would like to start with some history, and actually with some pretty old history and not related to Watermill. Maybe direct, not related. But when I was starting to code more or less 13 years ago, most of the tutorials for which we was able to learn how to code was looking more or less the same. I mean, it was starting with building some simple web applications, sometimes with some HTTP API, but it was not really starting with building some really complex event-driven application. And as far as I know, nowadays it's pretty the same. I mean, when you are learning how to code, you are not starting with building event-driven application, but you are starting rather with some synchronous website, sometimes with some REST API. But unfortunately, this kind of synchronous architecture or way of building applications, it's not silver bullet. It's working in some more simple cases. But in these times when a lot of companies is trying to create microservices architecture, sometimes in better, sometimes, well, in the worst ways, when we are using only a synchronous way of communication, we have some issues like cascading failures, slow requests between services, and coupling, which is also a pretty big issue. And 2 years ago, I was working on the project when we almost had some similar problem. And this project had two pretty important requirements. So the first requirement was kind of pretty advanced search engine. So it was advanced enough that it was kind of pointless to use some standard database like MySQL, but it was just much better to use Elasticsearch for that. And the second more interesting requirement was kind of personalization engine. So it should work more or less how it's working for Twitter, for example. So if you are adding a new tweet, if you are following some kind of people and you are following, liking some kind of tweets, you are automatically seeing more content of this type. And the idea was pretty similar, but it was one issue with that. So let's imagine that this part is done synchronously. And let's imagine that you are also followed by 10,000 users, for example, and adding this new tweet list, for example, for 1 minute. And I think it's not the best user experience. And also it's pretty hard to handle it from the technical point of view, because let's imagine that something went wrong in the middle of building this weak model for search, or something went wrong during this personalization. So I think it will be pretty hard to undo this. And I think it's also pretty impossible to have some kind of distributed transaction to handle all this stuff. So much better idea in this, and I think it's also some kind of standard approach, is using event-driven architecture in this way, and in this case. And some part of the team already have some experience with Kafka. So we decided, yeah, let's go with Kafka. It's nice, it's scalable. We don't need to change message broker later because, of course, it will be pretty hard. So let's go with Kafka. Well, you know how it is with problems. So in most cases, when you are fixing some problem, you have another problem actually instead of that. And what was the problem here? So I would say that there was a couple of problems. So first group of problems was some problems related to how actually Kafka or message brokers are working. So you need to remember about stuff like consumer groups, partitioning, at least once delivery, message acknowledge, and negative acknowledge. So you need to let your message brokers, for example, Kafka, that yes, I process this message. So in this case, it may sound pretty simple, but in case when something went wrong, so for example, in the middle of processing the message, your application died, you need to be totally sure that you will not lose this one message. And it of course depends on the domain, because in some domain, losing one message maybe not a big deal, but in some domain, for example, now I'm working with money a lot, so this one message may be losing some pretty big transfer of money. And I think it's not the best situation, so we would like to avoid this. But it was actually one even bigger problem. And this bigger problem was that actually building event-driven applications is not simple. So as I mentioned that when you're starting to learn how to code, you're rather focusing on how to build some synchronous architectures. And it was also the problem in our team that big part of the team didn't have any experience with this kind of architectures earlier. And after that, actually, I asked myself, I think, one pretty important question. And the question was how I can actually make building event-driven applications easy in Go. And by easy, I mean that it should be as easy as we are, for example, implementing HTTP router. And this is how actually Watermill was created. So currently, we can say that we have more than 2,000 stars on the GitHub. So probably even someone is using this library, and maybe it's even working for someone. At least for us, it's working pretty nice. Already 20 contributors helped us with building this library. We are supporting 8 different PubSubs. And what is the most important, we have logo. We have logo with Gopher vomiting to Kubernetes logo. Don't ask me why, but yeah, this is true, sorry. And from the totally beginning, the idea was that Watermill shouldn't be library, shouldn't be framework, because you know what is the deal with frameworks, and in general, frameworks are not working the best in Golang. So the idea was to create something which is not recoupling to your service, and you are able to easily switch from different solution to Watermill and vice versa. I hope that nobody will do this, of course, but still, okay, if you will decide that I found something better, so you shouldn't be coupled for that. So I have, for example, some experience with getting rid of Go Micro, so I would not recommend you to do it. It's not the best thing that you can do in your life, and here the situation is totally different. So you are also able to integrate with already existing infrastructure, even in different languages. So I think it's pretty nice part of library. And of course, you have a lot of configuration things. So of course, we are providing some standard configuration for that it's working out of the box. But if you have some more complex scenario, you're able to change really a lot. And as I mentioned, so we are supporting 8 different PubSubs. And what is also pretty interesting, switching between these PubSubs is pretty simple. I would say really simple, because I would compare it to how it's working with ORM. I mean, when you are using ORM, when you are changing dialect of the database, you just kind of changing some configuration, and it should work out of the box. Of course, as long as you have special infrastructure. And with Watermill, it's working actually the same. So if you decide for some weird reason to go from Kafka to RabbitMQ, for example, it's not really a big problem. And all right, everything sounds pretty nice. And you may ask, all right, but how is everything done? So at the totally beginning, when I started to think how Watermill should be created, I taken into account something which is named UNIX philosophy. And it's pretty old philosophy because it's from 1978. And it tells us to write programs that do one thing and do it well, write programs to work together, and write programs to, in our case, handle message, because that is a universal interface. And how it's look in practice. So I would say that in Watermill, there are 3 the most important types. So 2 first of them are publisher and subscriber. So you can use publisher, as you can guess, for publishing message to some provided topic. And subscriber, yeah, you're right. So you can just receive this message. I think it's pretty straightforward. And what is also pretty important, when you would like to add a new PubSub implementation, you just need to implement that interface. It's just this. Sometimes it can be some tricky stuff around, under the hood, but still, it's just implementing one pretty simple interface. And the third, even more important type is handler function. So handler function is kind of, I would say, heart of every event-driven application. So the idea is that in all the event-driven applications, you are receiving some message, you are doing some stuff, and later sometimes you are also returning some message, so emitting some message, and if something went wrong, you are returning error. I think it's pretty straightforward, and I will show you later it in the example. But going back for one moment to the UNIX philosophy. So probably some of you already know this guy. So, and if you don't know, so this is Ken Thompson. And this guy is actually author of Unix philosophy. But what is also pretty interesting in our context is also co-author of Golang. So I think it's also pretty interesting if you look on this Unix philosophy and how it's nicely visible in Go. And going for a moment with the Unix philosophy. So sometimes I have some feelings that maybe I'm thinking too much, but sometimes I have some kind of impression that maybe we are in kind of programming dark ages. And what I mean by this, so sometimes we have some good old philosophies that, it was written in 1978 or earlier, and for some reason it was forgotten. Even it's pretty valid still, and it's solving some problems that we are trying to overcome with some different techniques. It's, well, a bit forgotten. And I have even more feelings like this after reading this book. So probably some of you also know this book. So this book is The Pragmatic Programmer, and it was released 21 years ago. And okay, it's mentioning like Perl is a modern language and Python is some kind of language used by nobody, but it's also pretty interesting. But despite of that, I think it's a lot of nice ideas in this book that are still really valid in this time. And it's also not really nothing new, but I would say that you can find microservices there, some event storming, domain-driven design, and all these techniques, but it's not named like this, but it's pretty clearly described why we should do some things and why we shouldn't do something. So if you don't know this book, I will really recommend you to check this book. And as I know, it was also a new release of this book released previous year, as I remember. And so probably Perl is not mentioned, or it's not mentioned as a modern language, but I think it will be still even more valid than this release. But I was reading this release and it was also pretty nice. But yeah, maybe I'm thinking too much sometimes. So let's go back to the Watermill, I think. So testing. So testing is also a pretty important thing when we are using actually creating library like Watermill. And it's when we are building event-driven architecture, so it's processing actually every action that is processed by our system. So we need to be totally sure that we can trust that it's working as expected. For that reason, we prepared some actually a lot of tests. So we have a lot of unit tests, but we have also some pretty interesting integration tests for PubSub. And what is the most interesting part of that? Every PubSub is actually going through the same test suite. So it doesn't matter if it's Kafka, it's RabbitMQ, you are executing this test in this way. So you just need to provide some something which is named features. So you can set some characteristics of some PubSub, like exactly once delivery, guaranteed order, or stuff like this. But everything else is working in the same way. And it's pretty nice because when you are implementing a new PubSub, you don't need to really care about implementing new tests. You can just reuse the already existing one. And to also show you how powerful are these tests. So for example, we implemented Google Cloud PubSub without having access to any production system. And we was just using this test to ensure that it's working as expected. And after some time, after we had some opportunity to deploy it with some production system, it was working without any change. So I think it's showing in a pretty nice way how powerful are these tests. But it's still not everything about these tests, because we've also something what is named stress tests. So stress tests are ensuring that the Watermill is also able to work under heavy pressure. And the idea is pretty simple. Let's get the normal integration tests and let's run it 10 times in parallel. So you can trust me that it's generating a lot of load, and still it needs to pass, and every message that should be was published is delivered, or every time when, for example, we are closing application in some weird state, it should be redelivered. And I know about this load a bit because at the beginning I was running this test for entire night. So I think my laptop is remember that's better than me, because it was some kind of not the best experience for this, my laptop, but still it's alive and it's working. So yeah, but it was, yeah, not the best for him. And all right, and another pretty important thing. So how fast is Watermill? And a quick disclaimer here. So so we created benchmark for which is able to measure it. But what is also pretty important, we measured it in one process, because let's imagine that, okay, we can have a cluster of 100 Kafkas, we can have 1,000 processes, and later we can add double those. And I think it's kind of pointless, so I think it's just better to measure it in the one process. And let's go to the numbers. So, for example, Kafka is able to publish 70,000 messages per second and subscribe to more than 170,000 blah, blah, blah messages per second. So I think it's pretty nice. And as I said, so it's from one process and with one, yeah, so it was running in one virtual machine with Docker Compose with Kafka and with processing this virtual machine. So probably it can be faster, but I think it's just enough to have this one. But feel free to, because it's open, so this benchmark is open source, so you can also play with that and try to make these numbers bigger, or maybe optimize also Watermill code. So to compare, for example, MySQL pops up. And let's maybe wait for a moment with MySQL pops up, because you may ask, okay, MySQL pops up, what is going on? MySQL is a database. Yes and no, because I know some cases when it may be actually pretty useful. So I think I know at least 3 use cases. So the first one, the simplest one, is the case when the company just don't have infrastructure and don't want to invest in some extra infrastructure without some proof of concept. In this case, you are able to just use your good old MySQL or Postgres. So we are also supporting Postgres here. And you are able to use this implementation, and it will be good for the beginning, because okay, in theory, it can subscribe just to 143 messages per second, but it's still 20 million messages per day. So I'm pretty sure that out of applications on which you are working on, it may be enough. And as I said, so, but still, I would recommend to go for something which is more pops up if you are, if you can. But as I said, for the beginning, it's pretty nice. The second pretty interesting idea when you would like to go to MySQL pops up is that it's guaranteeing you exactly once delivery. So if you was already working with some message or event-driven architectures, you may know that most of the message brokers are providing only at least once delivery. And in this case, you are able to have exactly one. So in some cases, it may be pretty useful. And the third case when it may be useful, it's the case when you would like to publish some events and save some models in the database. So it can be also pretty useful. And I will not really go into details now, but at the end of the presentation, it will be linked to our blog. And in our blog, Miłosz described some nice usages of how you can use MySQL in some weird way. So for example, for this transactional or exactly once delivery. Also to compare, RabbitMQ is able to publish 2 and 4,000 messages per second and subscribe to more than 10,000 messages per second. All right, so probably some of you already know the first rule of live coding. So the first rule of live coding is pretty simple, and it say, don't do live coding. So let's do live coding. What can go wrong? So I prepared some code, and I think we can refactor that. So terminal is working, great. So what we have here? So we have Docker Compose here, and in this Docker Compose, it's nothing really fancy. Or actually it's one fancy thing. So we have container, application container with reflex. So it will reload after every time when we'll change anything about our application. So it's pretty useful when you are developing some application locally, if you are able to do this. Hopefully you are. And at least one service. And it's pretty useful because you don't need to recompile this and all this boring stuff. We have also Zookeeper, Kafka, nothing interesting. So let's check if it will be compiling. So this is my terminal here, right? Oh, and as you can see, it's working perfectly. It's also described, by the way, in our blog. So the second reason to check our great blog. All right, so let's check by example how our application is working. So in simple words, our application is some kind of room booking application. So we are able to book a room by REST API. So let's try to do this. Oops. Oh, now it works. Now it's not working. Now it's working slowly. Really? Oh, now it's not working slowly, so even worse. So I think it's not the best user experience for all the users that are using this application. So let's check in the code what is going on. So in the main function, we have nothing really interesting. So we have some chi router because I like chi. We have some signals handling and yeah, nothing interesting. But I think what is interesting will be here in the handler. So let's see what is inside. Okay, boring, reading body, boring, unmarshalling JSON, some advanced algorithm of calculation of room price, and taking payment. I think this is not boring. Let's check how payments are working. Yeah, as you can see, our provider is not the best one, but politics, we cannot change this provider. We need to live with that. So I have one pretty nice idea. So let's try, instead of taking this payment in synchronous way here, let's try to use Watermill and take this payment asynchronously. So my idea is pretty simple. So let's emit some event like room booked here and listen for this event and take payment after it will be emitted. So let's try. So the first thing that we need to do is getting rid of payment provider from here. By the way, I'm not sure which way you're liking to inject some dependencies to some handlers or whatever, but I like, for example, struct because it's much easier to inject some dependencies. So let's put publisher here. All right, let's remove this guy. So H publisher, and what we need to provide to publish. So as you may remember, we need to provide topic. So topic is some kind of, if you are not familiar with event-driven stuff, so I would compare it maybe to something like table or so. If you publish the message to this topic, so we are able to listen for every message which is in this topic. So let's name it bookings. And we need to also have a message here. And this is Watermill message, and it requires from us UID and payload. So UID is any string, and it can be even empty, but it will be not the best experience in debugging, I think. And payload is just slice of bytes, so it's allowing you to put anything here. So you can marshal it with protobuf, with JSON, with strings, whatever. So it's up to you. But we'll use JSON because I think it's kind of simplest way. So we need to have some event payload. And so we need to have also our event. And I have also some code snippets to not lose too much time for writing everything. So this event should be named room booked. And in room booked, we'll have room ID, guest count, and price. So we need to just create it now. So room ID is in request, guest count is in request guest count, and room price is here. Great. And now we need to marshal this. All right. I also don't recommend this kind of handling errors, but it's faster for live coding. But if someone will ask you why you are doing like this, please don't say Robert told me that this is how we are handling error. No, no, no. This is not like that. All right, so we are publishing this. We have error here. Oh, no. All right, so it needs to be like that. All right, so we have the first part. So after we'll inject some publisher here, we'll publish this room booked to this topic. And the second part is the part when we are so French sound. So the second part is the part when we will listen for this event and trigger payments. So it's named as I remember payments handler. And okay, and we have injected payments provider here. So we'll listen for this event that we just emitted here. And this payload that we are sending here is available out as this parameter that is sent, thus is available here. All right, so we need to have event, and event is room booked, like that. And now we need to take payment. So provider, take payment, event. No, it's price, like that. Of course, it's everything recorded previously, and I recorded that live coding with typos, so you will not see that it's recorded. This is my secret. All right. And here, I think it's at least one better thing in Watermill handlers than in HTTP handlers. So you are able to return errors. So you don't need to do something like this, or remember to send internal server error and do return after. So yeah, you can in a nice way just return error here. All right, and also let's maybe emit some event if we succeed. So payment taken. So let's rename that one. So room booked ID, room booked price. All right. Marshall and message. That is not too fast, but yeah, it's nothing very interesting, just marshalling JSONs. All right, so I think it should be everything here. Okay, so we are marshalling this event, taking payment, payment is taken, great, success. So the thing that we need to do now is some kind of glue these two parts, because, okay, we created some nice code, but it's not used anywhere, and actually we are not injecting any publisher here. So I heard that Kafka is nice and it's scalable, etc., etc. So let's use Kafka. So I also have some code snippet here, and I will not really cover this because it's everything in configuration. So this is just some default config with Kafka address, nothing more. So I will not spend too much time on that. So we'll just inject our publisher. So yeah, this Kafka publisher is implementing the interface that I described earlier. Yeah, you can see I was not lying. So all right. We need to also use our subscriber. So subscriber, in theory, we can use subscribe method, but it's kind of really low level. Fortunately, we have something which is a bit better. It's named router, but it's not HTTP router, it's message router. And the only difference is actually that it's not processing requests but messages, but so the idea is pretty similar. So let's use our router and let's add handler. So this handler will be named payments. We'll subscribe to bookings topic. So this is the topic that we used, where we use this? Yeah, here. So this is the, we'll listen for this topic. This topic will trigger this handler that we have here. All right, we need to provide now subscriber. So this is our Kafka subscriber, publish topic. So this is the topic to which we'll publish the payment taken event. So this one. So let's name it payments. We need to have publisher to publish that, and we need to have handler. So payments handler, handle like that. Right. So the only thing that we need that left for us it's running the router. Cool. So let's see if it's compiling. Service is starting. And starting. My Mac is burning. And yeah, success. So let's try to use our API. And as you can see, it's working. And it's working much faster, but it's working. So I think it's pretty nice. And I will use something which is named Kafka mill. So this is part of Watermill, but it can be used for consuming some messages from a message broker that you are using. And so if you have some experience with Kafka, it's working almost in the same way how it's working with Kafka. But the difference is that you can use multiple PubSubs here. So subscribe to this and mill to payments. So let's try to book some rooms. And you can see that messages are going here, and we are taking some payments. So we have, of course, some delay because our payment provider is as great as earlier, but at least it's now working. But all right, so we already did a lot of code, but let's try to add the new feature. And so let's use some imagination. And I think it's not a lot of imagination needed to imagine that some marketing team have some nice idea for some nice deal. And let's imagine this deal is that for every paid room, we would like to send a beer. Sounds good. So let's add a handler, and this time we'll use no publisher handler. So in this case, we are not publishing any event. So handler this subscribe topic payments. So this topic will trigger that. Subscriber is our Kafka subscriber and handler function. And as you can see, it's a bit simpler. So we are not we are only returning error if something went wrong. So we need to unmarshal our message as previously. Payment taken, like this, and so events. Right, so we'll just print some message that, okay, please send the beer to this room after we'll receive a payment. Well, let's try if it's working. Oh, where it is. Return. All right. What is going on? Of course. Well, this is the bad part of virtual conference. The normal one, someone will tell me at the beginning that I'm doing something wrong. Oh, as you can see, we're already ordering the beer. So what we processed the past messages because this is how Kafka is working. So Kafka is storing the old messages with some configuration. So we just have a beer for the old rooms. And as you can see, yeah, after everything was fine, we are sending the beer. All right, so we have some nice feature added. So let's maybe, yeah, I heard that, as I said, so I liked a bit that Kafka is nice. I heard that Google Cloud PubSub is nicer. So I have some kind of challenge to myself to try to change Kafka for Google Cloud PubSub in 1 minute. Do you think I can do this? I think I can. So let's try. So the first thing that we need to do is changing subscriber from Kafka 1 to non-Kafka 1. New subscriber. The second thing, what we need to do is changing this one to Google Cloud. So publisher, well, not like this. And Watermill logger. All right, and I think that's all actually. So I have also mill here. So let's use mill for Google Cloud PubSub. So we have also emulator working in the background. And let's see. Let's try to book a room. Oops. Something went wrong. Ah, it's not compiling. Yeah, Kafka go off. I think my Golang have not the best day today. But anyway, all right, it compiled. Okay, so we are sending the beer. It's a good sign. And even better sign is that, yeah, we have messages from Google Cloud pops up here. So I think it was pretty straightforward to change this. And I was not lying, yeah, that it's like with RM. All right, so we have this one. So just a quick look to some other features here. So one feature that I really like is named Middlewares. So you may know Middlewares from HTTP router, and here also this we have something which is named Middlewares. And it's working more or less the same. So you can have some correlation ID middleware, duplicator, which is pretty interesting, instant acknowledge, poison queue, random fail, which is someone pretty interesting to enable for some chaos engineering, recover, retry, throttle. Yeah, throttle is pretty useful. I know it from today. And you can also pretty easily implement your own one actually. So as I said, it's working like with HTTP actually. So no magic really. One thing that I would want to also show you, so this is some built-in metrics that we are supporting. So let's try to add metrics. So I have also one fancy snippet here, but because it's in examples. So I will not go in detail this, but this is the code that is needed actually to run metrics. The one tricky thing is what we need to do is in some way cover publisher variable with the interface. I mean, this is returning some specific implementation of publisher, so we need to cover it with the interface. So search publisher like that. Like that, and now it should kind of work, hopefully. Right, so it's compiled. So let's do some traffic. And I have somewhere Grafana here. Okay. I hope that you can see my Grafana. If you cannot, please say. And all right, so yeah, let's do some traffic. All right. So I already prepared some boring stuff with data sources. So we just need to use dashboard. And watch out, you need to use now a magic number, 9777. Don't ask me why. And okay, and we see that, okay, it's Watermill. So it's available, in this official registry of Grafana. And as I said, the magic number is 9777. And as you can see, it's actually working pretty nicely here. So you can see, okay, it's nothing interesting here because we have just three message handlers, but still, it's something, and it's pretty simple to add this. And if you are using Datadog, it's fine. As I know, you can use these exporters and just do some charts. It will be not as fancy and nice looking like in Grafana because Grafana is nicer, but yeah, it will also work. All right, so I think that's all from live coding. I think almost everything went great. I will just show you one more thing. So I also prepared some alternative interface how it can be done, because I used just some low-level interface to Watermill, I would say, but we are also offering something which is named CQRS, and this is actually allowing you to implement this event-driven stuff in simpler way. So what I mean by this? You just need to implement actually one interface which is providing handler name, event, and handle. And in this case, you don't need to care about any kind of serialization or all this stuff. So you are just returning event that is prepared by some magic code. And when you are emitting some event, you are also just emitting the struct. And all the marshalling is done under the hood. So I think it's pretty nice. And this is actually what we're using in daily work, but it's still compatible with Watermill. It's using the same router, so you are able to use middlewares and all this stuff. But it also depends of the use case, because not actually even every application is event-driven. Sometimes the applications are, so for example, you can easily do log stash with Watermill, but for this one will not really fit in best way. And so we have also a lot of examples with the CQRS, and as I mentioned, so it's totally serialization agnostic. So you can use JSON, protobuf, Avro, strings, I don't know, whatever you invent. So I will, if you are working in some application that may be really event-driven, I think you should also check this one. All right, so I think this is totally everything from the live coding. It was not so bad, but still, it's pretty hard to cover everything in 25 minutes of live coding still, I think. So, if you would like to use Kafka or Google Cloud PubSub or RabbitMQ, it's still a pretty good idea to check the internals, how it's working under the hood and what is something went wrong. I didn't cover also the topic of at least once delivery. It's covered more in our examples and documentation, but I haven't enough time for this today. So I just mentioned this CQRS component. I mentioned actually Middlewares. I already shown you this one. No, this is actually how it's working, and it's a lot of nice metrics here. This is screenshots from the documentation. So I heard it's pretty nice, but you need to check. And if I'm not lying, if I'm lying, please tell me, so we'll improve something, or you can even improve this because it's also on the repository, so you should be able to easily improve that one. Yeah, we have a lot of examples. So this is a list of just basic examples. We have more directories here, so you can check our GitHub for that. Yeah, and one small announcement actually. So even building event-driven application is not the only thing that I'm doing for the entire day. Actually, Watermill is just some small part of this, but in daily work, I'm more interested with some fancy techniques like I mentioned here. And a couple of weeks ago, we actually started some article series when we would like to cover this much wider topics that just event-driven. And I think it will be something totally unique in Go community, because we would like to really focus on practical solving some issues that we've seen in multiple projects earlier, and we still see in multiple projects. So I think it may be pretty useful for you. But what is also even more interesting, we're doing it by refactoring the open source application. So we created especially some serverless fancy application with some really small issues that are really small, but after 1 year they are pretty big, and they are stopping us for making this application better, adding feature, and everyone is not so happy to touching this application. So I think we'll pretty nicely show why, for example, some patterns may apply in some context, and it should be also pretty visible for you how to use these patterns and why it's pretty pragmatic. And I think it's also pretty interesting for us, because we are using this pattern in a daily basis, but I think it's also sometimes good to challenge some status quo. So I think it will be also pretty nice for us. And actually, we have already, as I remember, 4 or 5 articles, which are mostly describing this fancy application, which is named Wild Workouts. And it's also pretty nice, I think, because we're able to, with one comment, to deploy it to Google Cloud. It's working locally. It's a front end. Yeah, I did front end after a couple of years. It was scary, but okay, it was not so bad, but still, Go is better. And yeah, so here's actually a link to our blog. So I already mentioned that we have already a couple interesting things for the Golang development. This is a link to our documentation. And if you are using Twitter, this is my Twitter handle. So you can also follow me and see new stuff. And also in the blog, we have newsletter. So we are using this newsletter just for notifying about articles. And we are trying to release an article every week or every 2 weeks now. So I think it will be a lot of nice content. And I think that's all, actually. So thank you very much.